Okay, so get ready for this one, folks, because we're about to do a deep dive into some research that suggests smaller AI models can become ridiculously good at math.
Like maybe even rivaling the massive language models that seem to be getting all the attention these days.
Yeah, exactly. Like, can they really compete? Well, this paper we're looking at seems to think so.
It's called rStar-Math. Small LLMs can master math reasoning with self-evolved deep thinking.
Okay, rStar-Math. I like it. It sounds kind of like it's mysterious and powerful.
It is pretty fascinating. What they're doing is using techniques like Monte Carlo tree search.
I've heard of that. It's a way for AI to, like, plan out its moves strategically, right?
Exactly. So instead of just blurting out an answer,
like I do sometimes.
well, we all do it.
Okay.
But the point is, these smaller models are learning to break problems down into steps and think things through more carefully.
So more like a deliberate, step-by-step approach.
You're right, like a human mathematician might use. It's more like what we call system 2 thinking, which is slower and more analytical.
As opposed to system 1, which is that, like, gut instinct, quick judgment kind of thinking.
Precisely. And traditional large language models tend to rely heavily on system 1.
Which makes sense. They're trained on massive amounts of data, so they're good at pattern recognition, making those snap decisions.
But that can also lead to mistakes, especially when it comes to complex reasoning tasks like math.
Oh, I can totally relate to that. Like, when you think you know the answer right away, but then you realize you've completely overlooked something crucial.
Exactly. So with this rStar-Math approach, they're trying to teach these smaller models to be more deliberate, more methodical.
Okay, I'm starting to see how this could be a game changer, but I'm guessing it's not exactly easy to train AI models to think this way.
You're absolutely right. One of the biggest challenges is the availability of high-quality math data for training.
You'd think there'd be tons of math problems out there to use.
There are, but the really challenging problems, the kind that require deep reasoning, those are harder to come by.
And I imagine using large language models to generate more data wouldn't be ideal either.
Not necessarily, because they can make mistakes themselves, and you wouldn't want to train a model on bad data, right?
Right, that would just perpetuate the errors. So how did the researchers get around this data problem?
They came up with a few clever solutions. One of them is called code-augmented data synthesis.
Whoa, that's a mouthful.
I know, it sounds complicated, but bear with me. Basically, it involves using Python code to verify every step of the reasoning process.
So like a built-in fact checker.
Exactly. Each step has to be logically sound and actually produce the correct result. Otherwise, it gets flagged.
Okay, so no more cutting corners or making illogical leaps. I like it.
Yep, no more fuzzy math allowed.
Okay.
And then, to make things even more interesting, they use Monte Carlo tree search to assign a quality score to each step.
So steps that consistently lead to the right solution get a high score, and those that lead to dead ends get penalized.
Pretty much. It's like a reward system for good reasoning. But wait, there's more. They also have this thing called the process preference model, or PPM for short.
Okay, PPM, I'm intrigued. What does that do?
Think of it as a judge or a coach that observes the AI solving a problem and provides feedback on each step.
So it's not just about getting the right answer, but about how you get there.
Precisely. And the PPM isn't concerned with giving super precise numerical scores. It's more about learning to distinguish good reasoning steps from bad ones.
Ah, so it's like teaching the AI to develop good problem-solving habits.
You got it. And to put it all together, they came up with this self-evolution recipe. It's essentially a rigorous training regimen for the AI.
A training regimen. Okay, this is getting interesting. Like a boot camp for AI.
Kind of, yeah. It involves 4 rounds of problem solving, each round getting progressively harder.
So they start off with the easy stuff and gradually ramp up the difficulty.
Exactly. They begin with this curated data set of about 747,000 math word problems and gradually work their way up to problems you might find in actual math competitions.
Wow, that's a lot of math problems. So how did these smaller models perform after going through this intense training?
You're going to want to hear this. They tested it on the A.
Wait, the A? Like the American Invitational Mathematics Examination, that's for like serious math whizzes.
Yep, the one designed for high school students who are aiming for the math Olympiad.
No way. So how did a small language model stack up against those brilliant young minds?
Well, the 7 billion parameter SLM solved an average of 8 out of 15 AA problems.
Hold on, 8 out of 15, that puts it in like the top 20% of those students.
I know, right? It's pretty incredible. And it's not just about getting the right answers either. The researchers observed something really fascinating.
Okay, lay it on me. What did they find?
They found that these smaller models, after going through this rStar-Math training, were exhibiting signs of, well, it's kind of like intrinsic self-reflection.
Intrinsic self-reflection. Now that sounds deep. What does that even mean for an AI?
Well, it means that they were able to recognize when they were making a mistake during the problem-solving process.
So they were like, this doesn't feel right. Maybe I need to go back and try a different approach.
Yeah, exactly. Almost like a student double-checking their work and realizing they need to, backtrack or try a different strategy.
That's pretty mind-blowing. It suggests a level of metacognition that we don't usually associate with AI. Do you think this means AI is becoming more like human intelligence?
Well, I wouldn't go that far. Human intelligence is incredibly complex, and we're still a long way from replicating it in machines.
True. But it's still a pretty significant development, wouldn't you say?
Oh, absolutely. It's a step towards AI systems that are more self-aware and capable of more sophisticated reasoning.
And it makes you wonder what other capabilities might emerge as we continue to refine these techniques.
Yeah, the possibilities are really exciting. So apart from this whole self-reflection thing, what other insights did the researchers gain from this rStar-Math experiment?
Yeah, I'm curious about that too. What else did they learn?
Well, one of the key findings relates to the role of that process preference model, the PPM we talked about earlier.
The coach that gives feedback on each step of the reasoning process.
That's the one. It turns out the PPM is absolutely crucial for the overall performance of the system.
It's like they say, behind every great athlete, there's a great coach.
Exactly. The PPM seems to set the upper limit on the AI's reasoning abilities. So even once the SLM reaches a certain level of competence, the PPM still plays a vital role in guiding its further development.
So it's not just about providing feedback, it's about shaping the AI's thinking process at a deeper level.
Right. And that raises an interesting question. Could we apply this PPM approach to other areas beyond math?
Now that's a thought. Could we use it to train AI to write better code or maybe even compose music?
It's definitely a possibility worth exploring. The researchers believe this deep thinking approach has the potential to be generalized to other reasoning tasks.
That's both exciting and a little bit intimidating, isn't it?
It is, but it's important to remember that we're still in the early stages of research.
Right. It's not like we're going to have AI writing symphonies or proving groundbreaking mathematical theorems next week.
Not quite, but the fact that we're seeing these kinds of results with relatively small AI models is a sign that we're on the right track.
Okay, so we've talked about AI solving math problems, reflecting on its own thinking, and potentially even being applicable to other domains.
Yeah, we've covered a lot of ground.
We have, but I think it's time to step back and look at the bigger picture.
Yeah, let's zoom out and consider the implications of all of this. What does it all mean for the future of AI? What does it mean for us as humans?
Okay, big picture time. What are the key takeaways here?
Well, I think one of the most significant takeaways is that simply building bigger and bigger AI models isn't the only way forward.
We need to focus on quality over quantity, right? It's not just about computational power. It's about developing AI systems that can reason effectively and learn from their mistakes.
Exactly. And I think that's where this SLMs research really shines. It shows that focusing on the reasoning process itself can lead to some pretty remarkable results.
Results that could potentially revolutionize not just math, but many other fields as well.
Potentially, yes. But of course, with any powerful technology comes a responsibility to use it wisely and ethically.
That's a conversation for another deep dive, perhaps. But you're right, we can't just ignore the ethical implications of these advancements.
Absolutely. And as we continue to develop more sophisticated AI systems, those conversations are only going to become more important.
Okay, so we've talked about the potential of small AI models, the importance of focusing on reasoning processes, and the need for ethical considerations.
We've covered a lot.
But there's one more thing I want to touch on, something that really piqued my curiosity.
Oh, and what's that?
Well, we've talked about the AI solving problems, reflecting on its own thinking. But what about the PPM, that coach that seems to play such a crucial role?
What about?
The researchers found that the PPM can actually recognize when the AI correctly applies specific mathematical theorems.
You're kidding. So it's not just rewarding good steps in general, it's actually understanding the underlying mathematical concepts.
It seems that way. Like there were instances where the SLM correctly used Fermat's little theorem, and the PPM gave those steps high marks, recognizing their significance in the solution.
Wow, that's incredible. It's almost as if The PPM is developing an appreciation for the elegance and beauty of human mathematical reasoning.
It really is remarkable. It makes you wonder just how much these AI systems are capable of learning and understanding. I mean, it's really kind of mind-blowing to think about.
It really is. I mean, those small AI models tackling those really tough math problems and the role of the PPM in guiding their learning, even to the point of recognizing when they use those complex theorems.
It really makes you wonder just how much these AI systems are capable of, right? Like how much can they really learn and understand?
It is pretty remarkable, but it's like we keep saying, I think we're really just scratching the surface here.
Yeah, definitely. And this whole conversation has kind of brought up a pretty profound question, I think.
Oh, what's that?
Well, we've talked about AI's potential for self-reflection, right? And for maybe even achieving a deeper understanding of those mathematical concepts. But what does all of this mean for our understanding of intelligence itself?
That's a big question.
Right. Like if AI can learn to reason and think in ways that we've always associated with human intelligence.
Does it change how we define intelligence?
Exactly.
Yeah, I don't think there's an easy answer to that. Human intelligence is complex.
Yeah.
I mean, it involves so many things.
Like creativity, emotions, social skills.
Exactly. Things that AI hasn't quite mastered yet.
Not yet, but who knows what the future holds, right?
True. But I do think that by studying how AI systems learn to reason and solve problems, we might actually gain some new insights into how our own minds work.
Oh, that's interesting. So AI could actually help us understand ourselves better.
I think so, yeah. It's like AI is becoming a mirror, reflecting back our own cognitive abilities and forcing us to examine them more closely.
I like that analogy, AI as a mirror. It makes you realize just how intertwined these fields really are, like computer science and neuroscience.
Definitely. And that's why collaboration is so important. We need people from all these different disciplines working together to figure this stuff out.
Because it's not just about building smarter machines, it's about understanding intelligence itself.
Exactly. And I think those philosophical questions are only going to become more important as AI continues to evolve.
Well, I think we've given our listeners a lot to chew on today. From those small AI models tackling those really tough math problems to the PPM's role in shaping their learning, and to the really big questions about what it all means for the future of intelligence.
It's been a great discussion. Always a pleasure to dive into these topics with you.
Likewise. And to our listeners, if you want to learn even more about this research, we'll include a link to the full paper in the show notes.
Absolutely. Because as always, we encourage everyone to keep exploring and asking questions.
And on that note, we'll wrap things up for today. Thanks for joining us for this deep dive, and we'll see you next time.